This piece. So it's not. No, it's more. It's so it's like animals. It's.
It's same.
All right.
Yeah, I mean, RG.
Most of you guys showed me page 28 through 35, but I know that there's some confusion about 9.7. So I think some of you guys already showed me. So if you haven't shown me those last two pages, just show it to me at the end of class. Okay. I want to. We started a little bit with 9.4a, which is derivatives in polar form. So I hope that we can get through most of it today. Well, I hope we can get through that section so we can kind of be half the class ahead in terms of content. So I would like to start polar area today, but your homework tonight is just 9.4a, which is involving derivatives in polar form. I will review that a little bit, and then we'll just do practice problems for the majority of our class, and I'll introduce briefly into 9.4b at the end of class. Okay, so page 40. Page 40. Let me just do a recap. I know some students weren't here on Friday. This is on page 40. If I want to find the slope of a curve in polar form is going to take on the equation of x equals r cosine theta and x equals r sine theta. And if I can get that r in terms of theta, then if I want to find the derivative of y prime over x prime, I just have to find the derivative of r sine theta and r cosine theta. But we're going to have to involve sometimes product rule to get there. So once I get that, understand that I'm just doing r sine theta's derivative over r cosine theta's derivative, then we just know that it's product rule. We don't have to memorize anything like this. We just have to look at this and understand, okay, product rule, go to product rule and apply it. So, but you can just, those of you who work here, you can copy that down and we'll just go through the top of page 41, and we can just continue working through these problems. But I think a lot of this will feel intuitive because you already know how to go through product rule, and as long as you know how to start the problem, then everything else is going to feel familiar in terms of what we can expect from a derivative standpoint.
Like rectangular form, it's like take the derivative top and bottom, but not a product. I mean, not a quotient rule, right? Like
Exactly. Yeah, you're right. It's not quotient rule. It's just take the derivative top, take the derivative bottom, and then be done with it. We're not doing the derivative of like what you're saying. No, not quotient rule, right? Okay, page 41. We did this in class, but we can also use this as a way of kind of reviewing the concept before we move on to number 5. So it says, what's the slope of the line tangent to the polar curve at, or polar curve r equals 1 plus 2 sine theta at theta equals 0. Let's not worry about theta equals 0 first. Let's just worry about finding the slope of the tangent line. So slope is just change in y over change in x. And we can think of change in y as y prime of theta. and change in x as x prime of theta. So let's break everything down first, right? We know that y is r sine theta, and r can be thought of as 1 plus 2 sine theta. And we can get that 1 plus 2 sine theta. And sine theta, we can think, okay, I can just go through product rule here to get to y prime. But I think what I did though was I expanded first, and then I went through chain rule. But it's up to you. You can do whatever variation you would like. But either way, I went through chain rule here. Sine became cosine, and then sine squared, you're thinking of sine quantity squared. So 4 sine theta, cosine theta. This is my derivative. I plugged in 0 to get that y prime of 0 to solve out to be 1. And then I focus my attention on trying to get that x prime. So x is r cosine theta. X prime is just product rule, f prime g plus f g prime. And then plug 0 in for all the thetas. Some of it is, this is nice here, that sine of 0 is gonna wipe this whole second section out. Cosine of 0 is 1, 1 times 1 is 1, 1 times 2 is 2. So x prime of 0 is 1, sorry, y prime of 0 is 1, x prime of 0 is 2. So my slope gathering from polar form is 1/2. Okay, let's move into something new here, number 5. New problem. So number 5 says, find the value of theta where the polar graph r equals 1 minus sine theta. You can tell that this is the graph here. This is a yeah, so it's symmetric about the y-axis, we can tell. Cardioid, sorry, symmetric about the y-axis, cardioid. And with the coefficient and the constant adds up to be 2, so we can see that the diameter is going to be 2. Right, but the graph is wrong for us. Find the value, horizontal and vertical tangent lines. So let's just draw in our where we expect our horizontal tangents to be. How many horizontal tangents do you see on this graph? Where you can visually see a slope 0. It's more than 1, right? I see 1 here. I see 3. You guys see 3? Yeah. Okay. What's wrong with this point here? Why is this not? Yeah, it's not a smooth curve, right? This is a sharp turn. There's not gonna be a slope 0 here. So we can expect horizontal tangents here. Where how many vertical tangents do you see? 2, yeah. Okay, so we're gonna just use our ability to find these here. So I want you guys to copy this down here. So the slope is dy over dx, which is y prime of theta over x prime of theta. And anytime I'm looking for a horizontal tangent, I'm going to be setting that y prime equal to 0. If I set y prime equal to 0, that's where slope is 0. If I set the denominator equal to 0, so wherever x prime is equal to 0, that's going to give me the location of vertical tangent. Okay, we'll work it out step by step once you guys have this copied down. Now, if there's ever an overlap between what we find between horizontal and vertical, then we remove it, okay? It needs to be unique to y prime equal to 0 or to x prime equal to 0. If there's any overlap, we're going to remove that. Okay, so let's start on the horizontal side of it. You ever have this copy down? Okay, step by step here. So y is r sine theta. We know what r is. R is 1 minus sine theta. So let me establish that. Going to expand out here. Okay, derivative. I'm going to go through a chain rule here. This is really sine theta quantity squared. Okay, I can factor out. I'm going to set y prime equal to 0. I'm going to factor out my GCF there. Set both equal to 0. Sorry. Positive 1/2. Negative 2 sine theta equals -1. Divide both sides by -2. I get 1/2. So where's cosine equal to 0? Where's sine of theta equal to 1/2? First, second quadrant, yeah. That pi over 6 family. Okay, I'm not going to commit to these values just yet. I want to find out what's on the horizontal side of, vertical side of things. And I want to look to see, is there any ones that we can remove from both? If there's any overlap, we want to remove it. That means it's not horizontal or vertical. Okay, let's just gather from the vertical side of things. So vertical tangent, we're just going to eventually set x prime of theta equals 0. So let's build x first, then find the derivative, then clean it up, and then solve for theta like what we did with horizontal tangent. Okay, I'm just going to choose this case to jump into product rule directly, f prime g plus f g prime. Set x prime equal to 0. Can't quite use Pythagorean identity here, but what I can do is make everything into one trig function and then maybe look for factoring. So looks like I'm going to just work with that cosine squared, get everything. These two are already in terms of sine. I'm going to get this in terms of sine as well. we know that sine squared plus cosine squared is 1. So if I rearrange that, cosine squared is just 1 minus sine squared, right? Okay, look to factor here. Multiplies to be -1, adds it to be 2. I have -2 and 1. But it all factors out to this here. Let me see. -2 sin theta. Okay, I have my trinomial in factor form. Solve for theta here. I get sine theta is -1/2. Sine theta equals 1. Okay, where's sine equal to -1/2?
7 pi over 6.
Mhm.
11 pi over 6.
Third and fourth quadrant. Okay, where's sine equal to 1? All right, if we see any overlaps, we're going to remove it. You see any overlaps here? Yeah. So if you look over here, pi over 2, it's neither a slope 0 nor a vertical tangent, so that's why it's removed. So just like what we expect, 3 horizontal tangents and 2 vertical tangents. Okay, question so far? Yeah.
So if the slope is, wait. If this, never mind, never mind. Why isn't it pi over 2 and I think pi over 6 for horizontal? I mean vertical.
So a vertical, it's going to be 7 pi over 6 and 11 pi over 6. And then for horizontal, it's going to be 3 pi over 2, pi over 6, and 5 pi over 6.
Yeah, why did you leave out some solutions? Like the pi over 2 and
Yeah, the pi over 2 is basically at that sharp turn. It's a cusp.
okay,
So it's neither a horizontal tangent nor a vertical tangent.
okay, can I tell without looking at the graph?
Yes, because anytime there's overlap between horizontal and vertical tangent, you're going to remove it. It's neither. If it needs to be unique to either one or the other. All right, so 1 through 4 are actually 1 through 5 are review here, or pre-calc review here. So number 1 says find the corresponding rectangular coordinates for a polar coordinate 7 5 pi over 4. Let's think back on our conversion formulas here.
Okay, so X is R cosine theta, 7 cosine 5 pi over 4. Y is R sine theta, 7 sine 5 pi over 4. All right, number 2, find two sets of polar coordinates for the rectangular coordinate 4, -2. So to get from rectangular to polar, we're going to use Pythagorean theorem. We know x squared plus y squared equals r squared. And also we can use inverse tangent, right? Tangent theta equals y over x. So it wants two sets of polar coordinates. We need to find a theta. 4, -2. Now these are in radian measures here. So we know that tangent of theta is y over x. Tangent theta is -2 over 4. Solve for theta. We get -0.4636. Now, this is basically in the fourth quadrant, right? We know that. And so therefore, we know that, 0.4636 is really the reference angle. But from here, because we know this is the fourth quadrant, I can add pi to it and get something that is in the second quadrant. And I know that tangent in the second quadrant is acceptable. Now, -0.4636 normally would be fine, but we want something in that 0 to 2 pi range. So this is negative. This is in the fourth quadrant, but it's less than 0. So I can always add this plus 2 pi to get it into that fourth quadrant to between 0 and 6.28. So okay, so we know we're in the fourth quadrant, so we can say root 20, 5.819, or you can say 2.678, which is in the second quadrant, walk away from the second quadrant with that negative radius, and they both hit the same location in the fourth quadrant. Since the theta that we found is obviously in the fourth quadrant, we just have to present that 0.4636 in a better coterminal angle that fits in that 0 to 2 pi range. And the R is root 20 because that's the Pythagorean theorem to help us get to R from x squared and y squared. All right, number 3, convert a rectangular equation, x squared plus y squared equals 16. We want to get everything in terms of R and theta. We see an easy replacement there. X squared plus y squared is R squared. So R squared equals 16. So R is simply equal to 4. That's just a circle with a radius of 4, centered at the origin. Number 4, convert the polar equation. R equals 3 secant theta. You can think of 3 secant theta as 3 over cosine theta. Cross multiply, you can get that R cosine theta to show up. Okay, number 5 on page 42. Okay, it says sketch the curve without a calculator. Let's just see if we can remember what this could be here. What does that 3 theta tell us? Yeah, 3 petals. The 2 tells us, yeah, the length, right, or the diameter of each petal, and symmetric about the x-axis. Yeah. So we just pick a bunch of theta values between. Oh, and then this will complete a cycle. Yeah, complete a cycle from 0 to pi. Yeah, we can use our calculator, but we can also, I mean, on the test, you'll get to use your calculator, but here we can find these values. I'm sorry, I have the r and theta backwards here, but theta will help me get to the r. So 0, pi over 12, pi over 6, just enough for us to kind of have an idea where the points are going to land. We may not need as many points as I have here, but okay, let's look at number 6. Number 6, going back to what we talked about, to find the slope of the line tangent to the polar curve, we're ultimately going to do y prime divided by x prime. So let's build x and y first. X is r cosine theta, y is r sine theta. We have r in terms of theta. We make those substitutions. We have to go through product rule to build our y prime and x prime. Once we find the derivatives, plug pi over 2 in, and then we can do y prime of pi over 2 divided by x prime over pi over 2, and that is our slope at pi over 2. The product rule for both sets.
Any questions with number 6? All right, number 7, you're also building your x and y in terms of theta. So r is 5 minus 3 cosine theta. X is r cosine theta, y is r sin theta. Here's my x and here's my y. I do need to find x prime and y prime before I divide them by each other. But this one, I'm going to need what? Find the derivative. Yeah, so this one we do need quotient rule because within x and y, we do need to find the derivative within their respective equations. So
So 244 is going to be the three.
I'm sorry.
244 is going to be the three.
That's right. Yeah.
Now on page 44, number 16, that actually ends up being a parametric equation, a problem. So yeah, look back on 9.5 for 16 is kind of like a review from previous units is not, for previous section is not, doesn't quite fit in that polar, but it's still good for us to review. So yeah, just know that 16, you're look over your 9.5 and 9.6 formulas there. Okay, let's begin our notes on page 45. Anybody still need to look at number 7? Okay, so area bounded by a single polar curve. I think it's just good to know how to accumulate area. So just to recall in geometry, we learned that the area of a sector is 1/2 theta r squared. So a sector or a slice of a circle. And radius is some function of f of theta in terms of theta. So if I have a sector of a circle, this is my radius, this is my theta. And just want to kind of show you where this is headed towards. If you don't need to memorize it, this is just it's leading towards a definition that we're going to be using. So the radius of a sector is f of theta sub I. The central angle is b minus theta over n, which is delta theta. And our area of a sector, 1/2 theta r squared, is 1/2 delta theta f of theta sub I squared. And we're just basically adapting this into an interval formula. And ultimately, what we're going to be using is down here. Area is 1/2 r squared d theta from alpha to beta, from theta 1 to theta 2. If f is continuous and non-negative on the interval from a to b, then the area of the region is 1/2 r squared d theta. And we see that connection, right, between area of a sector and what we're using here.
You don't have to use that like infinity, right?
No, this is just to show where, we're basically adding. So this limit notation just indicate that remember how with area under rectangular graph, we would add up infinitely thin rectangles. And now we're adding up infinitely thin kind of pizza slices in these sectors. So, and they're going to fan out in a certain direction. They're going to fan out from the pole, and it's going to fan out just from one location and in counterclockwise direction. Oh, sorry, counterclockwise. Counterclockwise direction. Okay, and I'm really gonna, I think this is really helpful, especially if we're trying to figure out how to get to the area. It's nice to draw these, or just remind ourselves this is how area is found. It's not what you would expect between two curves where you just draw horizontal lines indicating rectangles. All of our regions will look like these sector slices or these pizza slices from one to the other, or from one end to the other. And it's all stemming from the same starting location. Everybody have this? Okay, let's see if we can get through example 1 and maybe 2, and then we'll be done.
So number one, it says find the area bounded by r is equal to 5 sine theta. Now we know a circle is going to complete a cycle from 0 to pi. So essentially this is how the area is found. It starts at the origin here. And because the circle is moving in this direction, imagine here it's just accumulating these sectors, and it's accumulating the area this way. And by the time it gets to pi, it would have added up all these sector areas to get to the area that we're looking for. So our area is just 1/2 definite integral from 0 to pi r squared theta. And all these, we can just use the calculator. We're not going to have to do this by hand. But the hard part is to be able to set it up, especially when we get to area between two curves or two polar graphs. The setup is always, it's just, yeah, that's once we get used to the setup, then the rest is just inserting into the calculator. Now, in your calculator, you don't have to be in polar form to get this to set up. If you're in rectangular form, you can still get the same answer. It's just that you're using x in your calculator. Now, if you want to be in polar form and to get that theta, you can, but you don't have to. Okay, if it's in the calculator, rectangular form or polar form will still get you the same answer either way. So don't feel like, oh, I gotta have theta to show up in my calculator for this to work. I can have x's in rectangular form, and this will still get the same answer. Okay, number two, this says find the area of the shaded region in the polar curve r is equal to 1 minus cosine 2 theta. We know that there is going to be essentially these two leaves here. This completes its cycle from 0 to 2 pi. So this shaded region is only from 0 to pi. One half r squared d theta. Okay, so we'll do our practice with this tomorrow, but your homework tonight is just to page 44. All right, come get your phones.
Integrate.
You can use your calculator to confirm, but to this graph, this is going to trace out from here to pi, and also you can just plug in order pairs
Okay.
to see that.
I was just asking because like the coordinates look weird. Like I wouldn't have guessed it.
Right, yeah, so, yeah, use your calculator and also use order pairs to confirm that there's a polar 0 and pi, so from 0 to pi, it's gonna complete the second first. You should have learned it. Okay, thank you. Okay, thank you.
It's the one. In my time, never been to Apple.
Right, so the bounds, you see how a circle, we know a circle is going to complete a cycle between 0 and pi. So if we're starting at 0, and this is 0, right, and it's going to keep building up until pi over 2, and then from pi over 2, it's just going to keep going until it hits pi. And by the time it hits pi, it's going to be back to where it started. So it's fanning out all these pizza shaped wedges until it accumulates from one end to the other. And by the time we get to the end, we can get that full area. We're accumulating all these pizza wedges from one end to the other.
When would it not?
Oh, it depends, right? We have to kind of think back on some of our shapes. Right. So all the circles are from 0 to pi. These are from 0 to 2 pi. These are from the odds are from 0 to pi. The evens are from 0 to 2 pi. But we can always, use our order pairs to help confirm. Okay, there's a polar 0. I see a polar 0, so I know it's completed math my cycle. You can also use your calculator as well. But I think enough practice. Yeah.
Yeah, we're gonna do.
I like.
Okay, that's incredible.
Yeah.
I mean, you have like triple
We're gonna start doing.
I mean, this thing, without.
We're gonna start doing a review on Thursday. So Thursday, Friday, and then I'll have help sessions Monday morning, Monday afternoon, and Tuesday.
It's I'm seeing like an event that I'm missing out Fridays. Be here for Thursday.
You'll be able to Thursday.
For Thursday, but not for Fridays, so.
Well, I'm gonna give you I'm gonna give you all 3 review packets. So I think once you see the first day, you can kind of just walk through that second and third with the key.
Oh, it has a key.
Yeah. I'll give you the packet and the key, so, and I'll record all the videos.
We have a session.
Yeah. So Monday morning, Monday afternoon, and Tuesday morning. Well, Thursday, you have everything that you need and then the key. So I think after seeing it Thursday, I think you should be self-sufficient at least for Thursday.
It's on next.
Yeah, next.
Yep.
I appreciate it. Yeah, thanks for organizing everything. Yeah, good job. Yeah.
Like that.
Yeah, sure. Okay. Thank you. Tomorrow.
I can give us all.
Yeah, I need to see. Yeah, I need to see these pages as well. Oh, this one is 6.
I was, yeah.
Yes, show me that 0.5, A and B.
Okay.
Next.